I want to go over the answers to this with you to make sure you understand what the right answer is and why it is the correct answer. All right, so first of all, this is a test I gave last year, and there are some things in here that were covered earlier this year, so these won't be on this test that you're going to take tomorrow, but I'll let you know, but it's always good to review. So number one, which reaction produces a gas that turns lime water milky? The gas that turns lime water milky is carbon dioxide gas. And so the correct answer to number one is C. Now that's a review question, and so that's not going to be on the test. Okay, number two will definitely be on the test. This is an equilibrium constant expression. And so they give you a balanced equation, and the N2, the H2, and the NH3 are all gases. And they would like for you to write the equilibrium expression. And so that's a K. And so a K is always the products. And so here we've got our products, NH3. So that goes in the numerator, NH3. The coefficient out front, the 2, is what you raise it to. So you got the products divided by the reactants, which is nitrogen and then hydrogen, and those are multiplied together, not added together. And then since the hydrogen has a coefficient of 3, you raise it to the third power. And so in this particular question, the correct answer was A. K was ammonia squared divided by nitrogen times hydrogen cubed. These were all gases. Here's what you need to know about writing a K expression. It's products, so what is on this side goes in the numerator. Any coefficient becomes an exponent on the thing. So for ammonia, the coefficient of 2 becomes the exponent for ammonia. So it's products divided by reactants. Again, it is always raised to the coefficient in the balanced equation. Do not include anything that is a solid or a liquid. So if there had been if this had been like liquid, an L for NH3, you would not have included that. But here, these were all gases. So you do include any gases or anything that has an AQ after it that is aqueous. Okay, so now we are down here, and this is Le Chatelier's principle, and you've got ammonia reacting with hydrochloric acid in equilibrium forming ammonium chloride. Remember, equilibrium is when the rate of the forward reaction equals the rate of the reverse reaction. We're at equilibrium, and now what has happened, you have let the ammonia and the hydrochloric acid escape. So this side is decreasing. All right, and so this is going down. To restore equilibrium, this reaction will need to shift to the left. And when it will shift to the left, and so that looks like this answer here, the reaction would shift to the left to produce more ammonia and more hydrochloric acid. So when you remove something, it shifts to replenish what was removed. Okay, the next one is what can act like an acid or a base? And the correct answer, remember, a Bronsted acid will give away a proton and a Bronsted base will accept a proton. Well, H3O would be a Bronsted acid, but it's not going to want another proton. It's already positively charged. Same thing with the ammonium ion. These are Bronsted acids, but they are not bases because they're not going to take on another proton. HOH is water, and water could give away this proton and act like an acid, or it could take another proton to form the H3O ion. So water is our correct answer. Okay, number 5, potassium hydroxide is an Arrhenius base. You need to know the definition. An Arrhenius base is something that produces hydroxide ions in solution, and hydroxide is OH minus. That is Arrhenius base. If this question had asked about like an acid acting as an Arrhenius acid, like HCl is an Arrhenius acid, acids produce H plus ions in solution. All right, the oxidation number for sulfur, we're looking for its charge. Barium is +2, oxygen is -8, and so that adds up to a -6. To make this whole thing balanced to become a +6, to make it 0, sulfur has to be a positive 6. If you were unsure of barium's charge, it is in group 2A. It's an alkaline earth metal on the periodic table. That's how you knew it was +2. Oxygen, excuse me, is -2. All right, this is a titration question, and this is not on this test, but hey, it's review. It could be on our final exam. As a matter of fact, this came from a North Carolina final exam. And so you see the word neutralization, and so that tells you use the MaVa equals MbVb equation. And so go ahead and when you do that, the Vb, the volume of your base, is 15 milliliters. And then you're solving for the molarity of the base, so that you're solving for Mb. The volume of your acid, this is nitric acid, HNO3 is nitric acid, the Va is 25 and the Ma is 0.75. Okay, so to set this up, it would be 0.75 times 25 is equal to the molarity of the base times 15. So 25 times 0.75 divided by 15, and the answer is B. 1.25 molar. All right, the oxidation number here, zinc is by itself at 0. Over here, zinc is +2. Zinc goes from 0 to +2. It has lost electrons. That is oxidation. And so we're going to look at A as our correct answer. This is our oxidation half reaction. The zinc goes to zinc +2 because it lost 2 electrons. Ammonia is considered a base here because it has accepted an H+, so it accepts a proton, and so the answer is C. Another titration question, the answer here is A. You have your acid, your Ma times 30 is equal to 24.6 times 0.5. And when you solve for Ma, you come up with 0.41. Again, the word neutralization or titration lets you know to use that MaVa is equal to MbVb equation, and then you just have to plug your numbers in the right place. See that this 24.6 goes with the 0.5 on the same side. They're connected with that word of. All right, here we go. Silver is +1 here, and it's 0 here. Silver has been reduced. It was +1 and it went to 0. So silver is reduced is the correct answer. All right, this is not on this exam, the proton concentration from a pH, but hey, it's good review. What is the proton concentration of hydrochloric acid when the pH is measured to be 6? Remember, the proton concentration is 10 to the negative pH. So it's 1 times 10 to the negative 6th, okay? All right, another redox reaction. This is on the test. If you want oxidation again, and look at tin is +2, it goes to +4 here. So we want the reaction where tin goes from +2 to +4 because it has lost 2 electrons. C is the correct answer. All right, this one, like the pH again, this is not on this test, but it was on previous tests. It's great to review. The pOH would be the negative log of 1 times 10 to the negative 4th. So the pOH is 4. They have asked us for the pH, so that's 14 minus 4, and the pH is going to be 10. pHs are never negative, so A and B can be crossed out. You know, here in standard chem and honors chem, it's not going to be negative. So now it is either 4 or 10, and they're asking about potassium hydroxide. That's a base. It should be above 7. All right, so there we go. I hope you did well. This just kind of touches the surface. We've got writing equilibrium expressions. We've got Le Chatelier's principle, what happens when you disrupt equilibrium. We've got Bronsted acids and bases, the definitions of acids and bases, assigning oxidation numbers, and recognizing an oxidation or a reduction half reaction. Okay, wow, I hope that helped.